So let's take a look at the video. So here I'll make a brief comment that after you printed the parts of your choice with binder jetting and made a sintering process, you get the pretty porous detail containing up to 30% of or even up to 40% of pore. And in some cases, customers are interested in such process as infiltration. So you put your, let's say, stainless steel part into the oven, connect it through the conductor to the special tank, which will be filled with bronze sand, and then you put this put this tank into an oven when at high temperatures bronze becomes liquid and infiltrates all the materials. So you'll got the stainless steel / bronze composite. So let's take a look about how does this take place. Sorry, somewhere over here. So it's the crucible for infiltration. Here comes the bronze sand. This sand is just for support. Often it's aluminum oxide. Then it comes to the oven, to furnace, where the infiltration process takes place. This process also requires the flat surface on the side of your part, which has to be specifically chosen by the operator. Who carries out this process of infiltration. So the only provider of these machines is the X1. So I used it materials because the binder jetting is owned just by the X1 company. Yeah, I've also added additional video on a little bit different technique. Let's also take a look. It's also binder jetting, but now we talk about the color binder jetting. So just to get you the understanding that the binder jetting can be used not only for creating the models for casting, but also using the sandstone for multicolor printing. So it's a more finer sand, which is used in this case, and as you might see on this slide with benefits and limitations, there's a different layer thickness for your parts depending on the material you use. So if you use the metal powders, it's about 50 microns. When you use the full color sandstone, it will be 100 micron, and if you use the sand by itself for the casting, it will be from 200 to 400 microns. So as I said, the dimensional accuracy is different for different materials. The typical build size are from 80 to 50 to 40 centimeters per metals, pretty close 50 to 380 to 230 millimeters per full color, and up to 2 meters by 1 meter by 60 centimeters for sand. So it's the biggest 3D printing technology to build casting models and master models for casting. So let's talk about the benefits. The benefit is that the binder jetting produces metal parts and full color prototypes at a fraction of the cost compared to DMLS and SLM, so it's much more cost effective. Binder jetting can be manufactured very large parts and complex metal geometries, and it's not limited by any thermal effects. The manufacturing capabilities are excellent for low and medium batch productions, especially due to these very big geometries which are provided with this method. Unfortunately, this method provides metal parts with lower mechanical properties comparing to DMLS and SLM technology, which we'll discuss later. Unfortunately, also only rough details can be printed with binder jetting because the parts are very brittle in green state, and you won't be able to provide the big complex shape because it will be destroyed during the post-processing with a high chance of crash. So comparing to other 3D printing process, binder jetting offers a limited material selection, so it's also a limitation of this technology.